Welcome once again, all my Form 3 students. As we are preparing towards our 2024 BEC this year, I have told you that we are going to be with you. So today we are going to look at very something simple in math that you might expect or you should expect in this year's paper. And we are going to look at bearings. Bearings. In this video, we are going to look at how to read bearings, both the compass bearing and the three-figure bearings using the Cartesian. We'll also look at back bearings. Yeah, so those are the two things we are going to look at today. Then the next we'll continue with what vectors. But today we're going to look at bearings. Very, very easy. Bearings. Now, just stay tuned and Form 3, so make sure you understand this and you can solve most of your questions. Now, what are bearings? So we say bearings. What are bearings? Bearings are basically directions given in angles. For bearing, we are giving directions. So I can give you a direction, but when I don't include angles, then that is not what? Bearings. But the moment I include angles in the direction given to you, then that is what I'm doing the bearings. So bearings are basically what? Directions. Directions given in what? In angles. In angles. So I tell you, 40 degrees to the north, this to the north, south, this, all those things are angles. And these angles are measured using the compass or the three-figure bearings. So in doing or in giving the direction, we can give the direction or giving direction with angles, the form of angles. We can do that in two ways. Either we use what we call the compass, and this was what in the old days they use what for their directions. Or we can use what we call the three-figure bearings. The three-figure bearings. We understand what all these things mean just in this video. So our objective here today is to know what bearings are, how to draw the bearing, and also how to apply to a back bearing. Very important. Good. So let's go deep into the compass type of angle that is given. We said this uses what? The four cardinal points. This is the four cardinal. What are four cardinal points? We have this. We have the east, we have the south, we have the north, and we have the what? The west. So when the direction given to you is you are using the compass, there's a way the person will give the direction. The person will tell that, okay, for this one, you move north 60 east, north 60 degree east. This kind of direction, this kind of bearing is one that's given on the compass. You get the point I'm making here. It's one given on the what? On the compass. If you are using a three-figure bearing, there's a way the person is going to say it. So take note. Then we are saying that always we move in the what? In a clockwise or anti-clockwise direction if you have measured the angle from the north and the what? And the south. So this is the main guy here. And if we are given a direction, we move either to the anti-clockwise direction or the clockwise direction, clockwise or anti-clockwise, depending on what we are looking at. The clockwise or the anti-clockwise, and the angle to which we are giving. So if I'm drawing something like north 60 degree east, then I'm going to look at the north. This is my north. Then from the north, I move 60 degrees to the east. The whole angle here is 90. So 60 degrees to the east means I have to move something of this sort. And this is where the bearing will be. This is north 60 degree what? 60 degree east. That means this is 60 and the rest is what? 30. Very important for the student to know this. How do you get the point I'm making here? Good. So that is how we measure the angles or the bearings on the what? On the compass. So if I have to draw any of these bearings, you should be able to draw. Take note that our main focus is on the north and the south. You don't have a bearing that will tell you west 30 north. No. The focus is on the north and the what? And the south pole. So if you have that, then we'll have north 30 west. North 30 degree what? West. If I'm going to the north 30 degree west, then this is my north. This is the west. So I'll go anti-clockwise. I'll measure 30. So 30 should be somewhere here. So that we have the 60 left for the what? The larger one. So this becomes that. And this will give us north 30 degree west. If I have south, let me take an example here. I have south 65 degree east. South 65 degree east. If I'm to draw south 65 degree east, I need the south and I need the what? The east. So that will give me south 65, so that would be 65 somewhere here. Good. So that would be my 65 what? Degrees. I hope you understand what I'm saying here. So this is basically one way of drawing what? Of drawing the directions. We'll come to the three-figure bearing soon. But this is what you should understand under the compass. So if I give you directions and I give you this, that means I'm giving the compass, or I can decide to give you the three-figure bearings. And this is very, very important for you to know the three-figure bearing. That's what we use mostly in our bearing calculations. Good. So now let's go with the three-figure bearings. For the three-figure bearing, I hope you understand what we have done here. 65, that if I want, let me try one last example for you. If I want south 40 west, if you are giving 45, that's exactly this. So we get what 45 this here. 45, right? That's exactly the middle. That's 90. So 45 will be here. I want 40. Or you are told that through north, through south, through north, through south, through east, so you just move on this. So now that's through north, through south, through east, and through west. But I want to draw this one for you. South 40 degree west. That will be south. This is my west 40 degrees. So I'll move some way, somehow that way. So this will be 40. I leave a bigger space for 50. You don't use a compass to the protractor to measure. So make sure you measure it sensibly. The 40 should be lesser than the what? Than the 50. Okay. So then the three-figure bearings. How do we also measure three-figure bearings? We measure that using what we call our Cartesian plane, our X and Y plane. So here is the X plane and the what? And the Y plane. So here we are using the cardinal point, which is the north, south, west, and what? East. But here we are using the Cartesian, which is X, Y, and what? Z. There's a Z, but don't worry about that. Now, this will give us the 0, because these are north, and we always start from the north. This will give us 90 degree, that gives us 180 degree, and this gives us 270 degree. Then we come back to our 360 degree. Once you go round and come up to a start point, you have completed a circle. But in the three-figure bearings, this is what we do. We use the angles instead of the north and the south and the cardinal points. Good. So that's very, very important. Now, we said in this, the direction is always from the north. Direction from the three-figure bearing is always from the north. If you are drawing a bearing of let's say 30 degree, and you are using this 30 degree, then you always have to start from where? The north. This is very, very important. The direction always starts from where? The north. So if I'm drawing this, then a bearing of this will give me what? 30 degrees. So 30 degrees something small, then I draw. Everywhere you end, if this is the end of your destination, make sure you put your Cartesian there. There's a reason why I'm saying it's very, very important. Anytime you pause, anytime you get to your direction and put the Cartesian there, because you might be turning again. So if you want to move again, you need a Cartesian. So every time, anytime you are doing bearings, or you are drawing bearings and you end, it will help you in the back bearings. The moment you end your line, draw a Cartesian. And the Cartesian, you shouldn't just draw it to fit exactly. Don't try and turn it. No. It should be straight. You can use the rule to do that and achieve a perfect drawing. Good. Now, there are some terminologies we need to know here when it comes to this. The question is, once you are moving, you have a destination and you have a start point. If you listen or you watch a video on integers, you know that I made mention of the same thing. That once you are going to a point, we need what? We need the destination and we need what? The starting point. Now, it's really a question, and the question tells you that we are moving from the bearing of A from tells you the origin. So if I say the bearing of A from B, that means B is my origin. That B is the start point. Very important for you to know this. And 2 is my destination. So take note of these terms when we are doing what bearing. Very important to you and to me that you know that if I read a question, I'm told that the bearing of A from B, the bearing of A from B, wow. That means that B is our start point. Because we are coming from B and we are going to where? To A. Right. These are the things one needs to understand and make it clear in the note. And anytime you take your note, you move in the clockwise direction. For this, you can move in clockwise or anti-clockwise direction. But when it comes to the three-figure bearings, you only go from in the clockwise direction from the north, not any point but where? The north. You get the point I'm making here. And I said you also understand what to and from is. When you hear from, that becomes your origin, the to becomes your what? Your destination. Very, very well. Very, very easy. Very, very easy. So when you are giving such bearings, always take note to what? To start your drawing from the where? From the north. Very, very, very important. Let's try some of these that I've said here. So let me just use this to try some. The bearing of A from B is let's say 120 degrees. The bearing of A from B is 120 degrees. The bearing of A is draw the bearing of A, or the bearing of A is 120 degrees. Draw the diagram for that. How do I draw this diagram? Now, we are using the Cartesian. We said that in the Cartesian plane, we have 0, we have 90, 180, and 270, then back to 360. And I said something that is so subtle, but you have to listen to that. Now, when you start moving, you are moving. You move from point O, right? You move from point O or point 0. Then you move from here to there. You have 90 degrees. So as I'm facing you, if I move this way, then I'm from here and I'm facing this point exactly, then I've moved what? I have moved 90 degrees. You get the point I'm making? So this is my north, and I move this way. That is what? That is 90 degrees for me. You get the point I'm making here? So from this point coming, you are moving. So you are moving 10, 20, 30 degrees, whatever. You are moving through 6 small degrees or small angles. Then you got to what? To your 90. So if you continue and you move, you get 90, 91, 92, 93. You keep moving small, little by little until you get to what? 180. You understand what I'm saying here? So as we are moving, that means 120 will be somewhere here. 90 plus 30 should give us 120. So if we move from the north, we have to get to 90. Then we move some 30 degrees. Then we can now get our 120. If you are not on the path that leads you to that, this is the path. So if you are going to A and you are at O and you are told to turn 30 degrees like we have here in this 30 degrees, and you turn 29, maybe 29 will be here, so you will not get to your destination. You go this point. You want to go to A. That's why they are using bearings. So turn 35 degrees. If you turn 30 degrees, the path on which you will walk to the place, you will not get to your destination. That's why it's very important. All this you are seeing here is the angle through which you are supposed to turn. So if I'm facing my north and I'm going to turn 30 degrees somehow this way, then I walk on the path to that place. If I turn 31, I'll change the path. Good, and I'll not get to my destination. So with that understanding, when the moment we begin to move from here, we get 90. We move to here, we've gotten what? Yeah, 180. Then from here, I want you to answer, we've gotten what? 270. Then we go back again, we get what? We get 360. That is why when we take the angles, when we do angles, the sum of angles that whose arc complete a circle will sum up to what? 360. Angles whose arc complete a circle will sum up to what? 360. Very, very important for you to know that. So now let me draw this guy. So the bearing of A from B. From B tells me that B is my origin. So this is my origin. I'll put B here. And I'm moving, I'm moving 120 degrees. So I'll start from the north and move 120. 120 when I start here, to this point, I've gotten to 90. I have not yet turned 120 degrees. So I need to keep what? 10. So I'll move from here. Then I need 30 more. And I add to that. So 30 more will be somewhere here. I want to be that, yeah, so somewhere here. Then I'll draw from this point. I'm starting here, so I'll turn to this point. I point here. Then when I get to my destination, then I draw my Cartesian here. So this becomes my what? My point A, where this bearing is 120. That is from here to there is 120 degrees. If I end here, I'll walk on this path. I'll not get to A. When I end here, I'll be on this path. I'll get to A until I've turned 120. Then I can get to A. Where this angle is 90 and that is what 30. When you add all together, you get what? 120 degrees. So I've drawn the bearing of A from B. That means B was my what? Origin. When you get to the back bearings or the back bearings, you are going to do the bearing of this type B from what? A. Now I want to go back to what? To B at A. What direction should I turn? What degree or what angle should I turn on for me to get the exact path to walk back to what? To B, because I'm at A. So if I want to go back to, that's what we call the back bearings. You are going back to wherever you came from. So we are now at A. If we want to do the back bearing, then we have to start once again from the north and move until we are on the path that leads to what? B. And that's what we refer to as what? As back bearings. Very, very well. Simple. Say explaining back bearings. So with this as well. I hope you understand this thing. I hope you understand this. Very, very simple. All that we are talking about here is that you have to read the bearing from the what? From the north. So I'll put some examples down. This time I will draw them, and I want you to read or let me to read what? The bearing. Here I wrote them and we have to draw. So what if I draw and we have to read the bearing? What if I have drawn and we have to read the bearing? No problem. Let's see how that is also done. So here we are supposed to draw the bearing. We're given this. Then we're told that we have what? This is our 48 degree. This is P. So at the end, then we put that. So that will be, let's say, A. So if we have this, the bearing of A from P is what? It's 48 degrees. 48 degrees. Remember, each of the corner is what? It's 90. So the reason I'm saying that it's 90. We'll use that sooner or later. I hope you get the point I'm making here. Now, if I have this diagram where this is my origin, and I draw a lot of the angles here, let me just put a lot of the angles to demonstrate something. So this is A, that is B, that is C, and that is what? D. These are all destinations around this. I go to A, B, C. I have to turn through so many angles. I want to go through this. If I want to go to B, I need to turn a particular angle B on this path that leads to B. So if let's say we have here to be 60 degrees, we have here to be 30 degrees. This is let me put 20 here and put something like 40 here. Now I'm supposed to find the bearing from this, that, and that, all from what? From O, which is my center. So I said, if I'm going to A, what would I do? I'm going to turn on a path that takes me to what? To A. What's the path? So I'm here from the north. I need to turn. What degree am I turning? I turn. What is left here? The whole thing is 90. So if here is 60, here becomes what? 30 degrees. Right? So the bearing of A is what? So the bearing, I hope you're understanding this. The bearing of A, if you don't understand, you always have the liberty to go to the comment section and ask your question. The bearing of A is what? Is 30 degrees. We can see that. But A from where? A from what? O. We don't want to add all that. Now let's look at the bearing of B. The bearing of B means, once again, start from the north. So this is bearing of A. Let me do this. The bearing of B. Now start from the north and move to the path on which you will walk to B. This is where B is. All these points will have citation. Just have not drawn them. All these points will have, so I can come back, I can come back. So I'll start from here. Then I'll move. I've gotten to it. I'm going to B. So when I walk on this path, it takes me to A. When I pause and I begin walking, I'll not get to B. So I need to turn, and when I walk here, I'll get to B. So until I get to the path, then I get to the path. So when I walk on this path, it takes me what to B. And the question is, from the north, what degree did I turn? That's the bearing. So from the north, I turn this from here to here. I've already covered 90. Then I've covered what? That this one. But I know here is what? This angle is 30. So here gives me what? 60 degrees. That means the bearing is going to be what? It's going to be 90 plus 60, which is 150. So now the bearing of B is what? It's higher than what? 50. 150. That's this plus that. So 150 degrees. Hope you are following. Let's try the bearing. So here I'm writing the bearings out of the drawing. Here I gave you the bearing and we did the drawing. This drawing is very important. So for you to move to SS, when you are doing the bearings in SS, you need to know how to draw these things very, very well. If not, you find yourself wanting. The point is that anytime you pause, put your cartesian. Very, very, very important for you to know that. Okay, now let's look at the other bearings. Now, what bearing C? You can work this out with me now that you understand. Let's work it out. Bearing C, what does it mean? It means we are going to C, once again from O. So we need to let me put bearing B here so that we know that for identification's sake. Then I start from here. Then I'm going to turn till I get to the path that goes there. So I'll move. I'll move 90. I'm still not there. I'll continue to move another from here to here. I'll move 180 and I'm still not there. Then I move this small angle and now I'm on the path. But it is 180 I moved so far plus the 20. So that gives me what? 200. Therefore, the bearing of C is what? Is 200 degrees. So I hope you can work the bearing of what? Of B. Let's work the bearing of B. So let me put C here. So this is the bearing of C. Let's work the bearing of B. Once again, we start here. We move through. Let's move very far. That's 90, 180. We're still not there. We've got 270. We are not there. No problem. I need that to add some 40 more. So we add some 40 more. So our bearing is going to be 270 plus that. That was some 310. The bearing of D is now be 270 plus 40 will give us 210 degrees. Very, very well. Simple. Very, very simple. I hope you understand how to read the bearings and how to draw the bearings. Good. With this, I want to introduce or end the lesson with the back bearing. This time, we get to the point. We use this to explain the back bearing. Back bearing simply means that once we go to the destination, we need to come back. It's what? Let me read something from here. Back bearing is the reverse of your initial bearing. Simple. That is, return from your walk, your journey. Very simple language here. The reverse of your original bearings. So from here we came here. If you want to reverse, that means we start from the north and move this way till we touch this. Then we move in this direction. What angle are we sent through, or what is our angle? That's what we're going to look at. And that angle refers to what? Our bearing. But bearings are directions in what? In angles. You can try more of this from your master's books. Try more of this from your master's book. You know what I'm talking about here. It's very, very well. Simple. So now let's tackle back bearings. Back bearings. I've already read everything. I just want to make everything clear for students. That is all that I do here. That's all that we are doing here, to make sure you understand into depth all these things, you don't get confused, right? Good. So we are saying that for the back bearings, we are going in a reverse order. So I move from, I'm standing here, and I move here, and I went this way. If I want to go this way, it means I have to turn once again. In what direction? So I'll be on the path that brought me to wherever I am now, so that I can go back to my origin, which is my starting point, right? Good. So let's understand this. So what we mean is that if we have the bearing of A from B. I just take the bearing of A from B. A from B means B is our origin. So we start here, and let's say we send some degrees. So we go here. Now we ended here, and that's our Cartesian. This bearing is our initial bearing. This is our initial bearing. So that's the first angle we send. So this is B, and that is what? A. Now I want to return to B. And once again, we said always our direction is in the north, in the wall. We take the direction from the north in the clockwise direction. So now that we have finished our transaction, we want to go back. We want to go back to B. What bearing should we use? Now look at this. You want to turn from here. If you end here, you will never get to B. Look at the path you use. If you are here, see the path you will follow. If you are here, see the path. So you need to continue turning yourself until you're on the path that takes you to B. Then when you walk on this path, you get to B. But the question is, from here to here is 270. So what is the value of this small angle? That's what we call our alternate angles, or our Z angles. And alternate angles, we use a Z here. So if you look at this Z here, this thing gives you a Z, a parallel line and a transversal. That means whatever angle we have there, if the angle here is X degree, then the angle here will also be what? X degree. That's how we get it. So once we add this to whatever angle we have moved, we get the backward bearing. So this will give me what? Will be our back bearing. This is the initial bearing. This will be the back bearing. So this will be the back bearing. Why back? So because we start from what? The bearing of A from B is this. Find the bearing of what? B from A. I'm going to take an example. Look at how back bearings are. That bearing are fun. So this is how we do back bearings. Very, very well. Very, very simple. Let's take an example. Let me use that to explain again. Then we'll be out of here. We end the video, very short one. I'll meet you again. And that is, we are going to do vectors. We are going to do what? Vectors. Look at what vectors are and how to add magnitude of vectors, reverse vectors, and all that. Now, before that comes, let's end this one. So if the bearing of y from x is 60 degrees, if the bearing of y from x is 60 degrees, if the bearing of y from x, therefore, that means that this x becomes our origin. If the bearing of y from x becomes our origin, is 60 degrees. So for 60 degrees, we start from the north, it should make a so from here, then we draw. Yeah, so this small space can be 30, so these are 60 degrees. When I report, we draw our Cartesian. Once you know the Cartesian, we are at what? We are at y. So now at y, when we do our z angles, we are going to get here to what? 60 degrees. The z angle, look at the z. From here to there now is 60 degrees, right? Look at the z I choose. From this and that z, this means 60 degrees. I hope you get the point I'm making here. Good. Now, if I'm Y and I want to go to X, what degree should I turn? Once again, from the north, this 90, 180, then plus this. How we get a point I'm making? So now the back bearing, which is the bearing, which is the bearing of this time X from Y. The first one was Y from X. That's what we've drawn. The 60 degree. This time I want the bearing of X from what? From Y. From Y. So Y becomes our original. Then we turn. So we turn to here, we get 90. From there, we get another 90. Then plus that. So it will be 90. How many things? 190 standard terms. Another 90 plus the what? 60. That will give us 180 plus what? 60. What is 180 plus 60? That is 0. This will give us 10. That's 14. So 240 what? Degrees. Therefore, our bearing equals what? 240 degrees. Basically, this is how the bearing is done. Basically, this is how your bearing is done. Very, very simple. Very, very simple back bearing. So this is my back bearing. Let's try that example. Then I give you some short way of doing bearings in case you have section A. There's no need to go and draw all this. But this is very important for the students to know. Very important. I know why I'm saying that. Good. Now, if the bearing of P from Q is 245 degrees, if the bearing of P from Q, that means Q is our origin. So if Q is our origin, it's Q. We are going to what? P. So the bearing is 245 degrees. So we start from 90, 180, we want 245 degrees. So for 245 degrees, we are going to move 65 more in addition to the 180. So we get this. Or this gives us 65 more. So this will give us what? This 65 more. That was 90. That was 90. So then to P. Now let me just use a very good line. Okay, then to P. Always your line should be straight. So these are points P. When we do our Z angles, the angle here becomes what? 65 degrees. Now we want the bearing of Q from P, the bearing of this time Q from where? From P. We are doing the bearing of Q from P. So P becomes our origin from the north. Then we turn to the path and we go. And that is very simple. We go what? We got 65 degrees. So the bearing is what? 65. Unlike this one, we have to add. This one just 10 and we are there. So that is how to do the bearing. But this is the hint here. This is section A. If the angle given to you is less than 180, like for instance, the bearing of Y from X is 60 degrees. It says 60 degrees. Now find the back bearing. We have to go and find the back bearings. We have to go and find the back bearings. To find the back bearing, very easy. What do? Since the angle given to us is less than what? 180, add it to 180. So that'll be 180 plus 60 degrees. And once again, that gives what? 240 degrees. So if the angle given is less, add it to it. The angle given is more than 180, subtract the 180 from. Like this, we're given what? 245 degrees as the bearing of P from where? Q. So the angle given is more than 180. Subtract the 180 from the angle. And 180 from this will give you 65 degrees. So this is the simplest way of doing it in case of section A. If you are drawing it in an exam and you made it in your SS, then this I've taught you is very powerful and you need to know. You need to know how to do it. Good. So that's the end of our vectors, our bearing, sorry. Good. Next time we meet, you are going to look at our vectors. I'll upload them notes so that you also go and there are examples that you need to solve. If you have any challenge, you know what to do. Just go into the comment section and put your question there. So in the comment section, you ask your question. Thank you very much for joining our class today. Shall meet